As technologies advance, humans have been looking to automate more and more tasks. In the past couple of years, we've seen a rise in one particular area, autonomous vehicles, more commonly known as self-driving cars. Autonomous vehicles utilize several advanced technologies in order to navigate their environment while keeping passengers, pedestrians, and other drivers safe.
My name is Kevin Matthews.
I'm Michael Day.
And my name is Colin Pacella. In this video, we're going to dive into some of these technologies to understand how they really work and how they can be improved. For our experiments, we used a JetBot equipped with a camera and an April tag. These allow the JetBot to perform 4 functions that are essential for our autonomous vehicles: position detection, path planning, path following, sign recognition, and kinematics. These functions require inputs that are gathered from the camera, utilizing the April tag, or from processing using computer. Before we can jump into using these functions, we need to make a flow chart of what the inputs are for each function. Each function has inputs and outputs. Some functions use the outputs of other functions as their inputs. This is why it is important to plan everything out first, so we know what functions must be performed first and how they contribute to the next function.
First, we'll discuss position detection. Our JetBot connects to the camera bot to read the April tag and get information like coordinates and heading angle. The camera bot is hung from the ceiling and has an overhead shot of the entire course as well as the April tag on the JetBot. From there, calculations are run using the image captured by the JetBot to plot a route between the robot's starting position and end position. This is done by performing conversions like pixel to real scale conversions and converting the JetBot coordinates to the camera bot coordinates. From here, we can set a number of nodes or positions on the track to which the robot can go to. We also set a minimum distance of one node to the next, which results in more efficient JetBot movements. We can also use this to find the quickest path from an initial node to the final node. The angle from the node the JetBot is currently at to the next node it is driving to allows the robot to know if it needs to go straight, left, or right. Our set angle was 40 degrees but could be adjusted if the JetBot makes turns when it should or goes straight when it should turn. The JetBot then begins moving using path following. This consists of the robot receiving the image from its camera and identifying the yellow line on the road using HSV values that filter out everything except the yellow line. The JetBot can track the yellow line and make adjustments using a PD controller.
While the JetBot moves along the path, it also checks for signs and reacts to them. This is done by training a model that is able to recognize traffic signs in different environments. We did this in Lab 2 by taking numerous photos with our JetBot with the condition of having a sign in front of it and not having a sign in front of it. This initial data was used by our program to accurately recognize the presence or absence of a street sign. For our demonstration, we used a stop sign at the end of the path to put the robot at its final stop. When the robot comes to an intersection, it can't follow the line anymore. To overcome this, we use simple kinematics to navigate the turn. We collected movement data to find the turning speed, and from there calculated the amount of time it needs to turn based on the angular velocity of one wheel. From this, we could calculate how much time it would take for the JetBot to turn 90 degrees. For our demonstration, we first used the April tag to find our starting coordinates and heading angle. From this, we used path planning to find the shortest path to our end destination. The JetBot then uses line following until it arrives at the first intersection. At this point, we used our basic kinematics to have the JetBot turn left, drive straight until the next intersection, and then turn right. After it makes the right turn from the intersection, the JetBot locks onto the center line again and follows it. During this period, it is looking for the stop sign every 2 seconds. Once the JetBot sees the stop sign, it will stop. We added a 1-second delay before the JetBot stops so that it drives all the way up to the sign before stopping. As you can see, our JetBot accurately traversed the path as intended successfully multiple times. Thank you for watching and have a great day.